for this class, Math 152B, we are only going to learn one thing. It's called solving quadratic equations and some other miscellaneous thing. You will find out what is a quadratic equation later, okay? So this week, we are going to do the miscellaneous thing first. At the same time, review what you have learned in 152A class. Okay, so in 152A class, what did you learn? 3 things. First thing was solving linear equations and inequalities. Second things are graphing linear equation and inequalities, right? Third thing was what? Polynomials. So today we are going to review the graphing, okay, your line again. We are going to solve system of linear equations by graphing. In 152A class, you only graph a line, right? Now we are going to do something called system of it. That means more than one line, okay? Then look, we started from page 1. You should have your class notes printed out in front of you as we go along. You can either print it out, the blank one, follow along and write it down, just like you are in a classroom. Or you can print it out, the package for the notes with all the answer keys to follow along as well. Either way. So we are on the page 1. That will be your textbook for this class. So all the informations are in there for what you need to learn, okay? So we are going to, first we review the graphing, but instead of just one line, we might do 2 lines. So we are going to use 3 methods to solve the problem. If we have 2 lines, they might meet one place, right? If 2 lines, they might be this way, they will never meet, right? Another one is, one line is here, another one is the same on top of each other, they meet forever. So we are going to solve where do they meet, okay, by graphing today. There are 3 ways of solving it. Let's just write it down first. And first method we are going to use is called graphing method. Second method would be something called substitution. Third one is called elimination or addition. Different methods, 3 methods we are going to use. We'll gradually introduce them one by one, okay? Before we talk about, how to decide what kind of situation, and we just review the graphing first. So see how much you still remember, okay? So look at your page 2. Let's review first. For page 2, that would be, let's do part 3 first. Okay, then see some examples, then see what we are doing, okay? So here's a solve a system equation by graphing. Let's just do it one by one. If I have two equations, negative x plus 2y equals 10, x plus y equals 2. In your 152A class, if it's a linear equation, when we graph it, it should be a what? A line, right? And for a line, we learn two forms. One is what we call it standard form. Okay? And for a line, when we graph it, we have what? How many variables? Two variables, x and y, when we graph, right? With power of 1. Standard form of linear equation is what? ax plus by equals c, right? Both x and y are on the left side of the equation. A, B, C are real numbers, and A, B are not both zeros. Okay, if both zeros, then you don't have an equation. Another form you have learned is called what? Remember this? Slope-intercept form. Right? Then it's an equation. Then you only have an x and y with one power. And slope-intercept form is what? You have y and x, right? And slope-intercept form, you have what? The slope and y-intercept. So only y on the left-hand side of equation, y equals mx plus b, right? We learned these two forms in your 152A class. So for the first example, first one is what? Linear equation, right? Second one is the same thing. And they both are in standard form. But when we graph it in your 152A class, either form you can just use what? T-table to do it, right? So for the first one, we have what? X and y, right? We just use the what? Simple method. We use, how about 0, 0? Use with intercept to graph it. So when we put in the first one, and what do we have? X is 0 for the first equation, right? So negative 0 plus 2y is 10. Then what is your y? Divided by 2, right? So that would be 5. And for y 0, you plug in, that will be negative x plus 10. So what's your x? That would be negative 10. Right? 0, 5, and negative 10 is 0. Is that right? Let me see. That's correct. When x is 0, y is 5. When x is negative 10, y is 0. So, when we graph it, what do we have? 0, 5. Right? Another one is a negative 10. Negative 10 and 0. So when you graph, the line looks like this. right? So if we have, for the second one, x and y, x is 0 and y is 0. When x is 0, you plug in 0 plus y, that would be 2. Y is 2. When y is 0, x plus 0 equals 2, y is what? When y is 0, x is 2. So 0, 2 is here, right? 2, 0 will be here. So this line will look like this. Remember how to graph your line? So where do they meet? They meet somewhere here, right? If you need to have a ruler and lined up nicely, and so you can find the point. Otherwise, it's not accurate. So for the first method, it will not be so accurate. You have to line up everything. So this meet somewhere around, we are just guessing, -2 and 4, right? I think. So, but we cannot see it exactly. So how do we know we are doing right? That's the right point. So you need to check, to plug in again. For the first one, take a look. X is, see whether or not this point works, right? So negative 2, right? Plus 2, y is 4. So add up is 10 for the first one. Yes, this point will be on the black line, right? If the point is on the line, then it should work for the equation when you plug in. Is that right? Okay. See if it works for the second one. So second equation, we'll plug in -2 plus y is 4. Is that 2? Yes. Then we know it works for both, right? That's how we decide whether or not the points are on the line, by plugging. But this one, it has to work. We say you have 2 lines to see where they are meet. The point has to belong to both of them. That's why you need to check on both of them, right? So then look the second example. We are reviewing how to graph your line. -4x, right? We can just use t-table to plug in each of them. So for the first one, x and y, so x is 0, you plug in 2 times 0, 0, so y is 7, right? We just find a few points. X is 1, 2, then y will be 5, right? X is 2, you plug in, that's 4, so y will be 3. So when we graph this line, it will look like what? 0, 7, right? 3, 5, 1, 5, right? Not 3, 5, 1, 5, and 2, 3. So you mark a few points, usually two points or 3 points for the accuracy. Just make sure they are on the same line. So you will have a line like this for the first one. For the second one, you do your t-table, right? So your x is 0, y is 0, x is 1, you plug in -4 divided by 2, so that's -2. And if you plug in x is 2, that would be negative 8 divided by 2, negative 4. So the line will look like, okay, 0, 0, 1, negative 2, right? 0, 0, 1, negative 2. 2, negative 4. 2, negative 4. So when you graph it, you find out these two lines look like what? Parallel. If they are parallel, what do you think? Will they meet? They will not meet. So if they don't meet, do we have a solution for those two equations? No. Why? Because wherever they meet is the solution for both equations, we call it, right? So the solutions must be on both things to be able to call it a solution, right? So for this one, what would we say? Your x and y. So for the first one, then negative 4, negative 2, 4 is answer. So usually you write it out, your answer, negative 2 and 4, right? That's where they meet. Then this one, they don't meet, so you say what? No solution. Why? Because the two lines are parallel. So we just review the lines, how to graph them, right, by 3 points, then see how these two lines behave and where do they meet. So one condition is what? The first one, the both lines they meet at one place, right? The second one we just did is what? Two lines parallel, that would be no solutions. Let's look at the third example. Third example here. Those are still written in the standard form, right? So we just use t-table for the first one. X, y, x is 0, you put in 0 and become what? Negative y is 3, so y will be what? Negative 3, right? Then for the second one, we haven't finished the line yet. So if I put a y is 0, x become what? 3. So when I graph the line, I shall have what? 0, negative 3, and 3, 0. Right? And for the second line, I will do my t-table. If I just use simple 0, 0 point as the intercept, or 3 points for x, either way will work. X 0, y is what? X is 0, y is negative 3. Then y is 0, negative x equals negative 3, x is what? 3. So 0, negative 3, are they the same line for both of them, right? So how many solutions there are? How many places do they meet? Everywhere on the line. So we say what? X and y, we have what? Infinite number of solutions, right? formally, if you answer this in the class, that's good enough. And we understand what you are saying. Formally, in math, then we need to describe, oh, those are all the points they meet, many, right? So we use bar. After the bar, then you use the formal way to describe it. XY is not anywhere, somewhere else, but on this line. What is this line? You can just pick one because they are the same. Then you use the curly bracket to put them in there. So those are formal symbols of math to describe those lines. Actually, there are many points. Okay, so we just did what? Try to find a system of solutions, right? Linear equations. So one is midpoint point. Another one is what? Parallel, you don't have a solution. Another one is, we just did, then two lines are overlapping with each other. So you have infinite solutions. Okay, let's go back to your page 1. Let's go back, see what they were talking about for the solution. We do it in a more formal way. Okay, so let's go back for the vocabulary. Okay, so how we will describe a system of linear equations, right? So it means what? You must have what? Two or more linear equations. Then we do it here, two variables, two equations. We call 2 by 2. Next class in your math 154A class, you will do 3 by 3. 3 equations, 3 variables. Okay, so we start from here. And so what is a solution? Solution means what? If it's a solution, it must be what? And the place where they meet, like this, right? Where they meet is called x and y's. We call them what? Ordered pairs. That is a solution for both equations. So now you can look at the example to decide, oh, if I give you this point, I say, is this point a solution for the system we have? System is 2 lines, right? You say, with this point, works for that. How do we know? It has to be on both of the line if it works, right? So we plug in the first one. So you plug in the first one. So x is 12. 12, 2 times 12 minus 3 times 6. Is that 6 for your first equation? 24, 8 minus 18. Yes, you work on that. How about second one? On the second equation, is 12 equals 2 times 6. Is that right? Yes, it is. So we say this point works on both equations. Then we say this point is a solution of the system. Take a look, second one. Okay, it says, is this point worked for these 2 lines? So what do? We plug in the first line, right? Plug in the first one, see if it works. So -1 plus 2 times 2, is that 3? Yes. So it worked for the first one. It means it's inside of the line. How about second one for this equation? So you plug in 4 times -1, right? Minus 2y is 2. So is that 6? -4 minus -2. No, not the 6. So this point is not on this line. So we say this point is not the solution for the system of equations we have. Let's come back to the page 2 on the bottom, conclusion. So we just find the solutions, like 3 examples we just did, condition like that, right? So you have 2 lines. How do they meet? 2 lines, they might meet like this. One point might be parallel. Many, they will not meet. Or overlaps, then they will meet many points, right? So we say they have those different types. So type 1 is how many solutions? 1 solution, right? Then type 2, how many solutions? No solution. And type 3, they overlap each other. So how many solutions? They have infinite solutions, right? We know this situation. Now let's take a look the page 3. Okay, so we know 2 lines have this condition, right? So 3 conditions. So for this one, what do you think? We say if the slope goes up and down from left to right, it means the slope is what? Positive. If goes down, slope is what? Negative, right? If level, it means what? Slope is 0. Then if it's vertical, we don't have slope. Slope doesn't exist, right? Or undefined. So then let's look at the situation. If 2 slopes, if they are parallel, what do you see? They should have, if they are parallel, right? So if they are parallel, so 2 slopes should be the what? The same, right? Then how about overlap? The slopes are still the same. Right? Same thing. However, for the y-intercept, so if you have y-intercept here, take a look. That's the y-intercept, that's the y-intercept. They have same slopes, but they have different y-intercepts, right? Then for infinite solutions, when they overlap, besides they have same slope, they have what? Same y-intercept. Right? So that's the difference between those 2 situations. How about this one? If they have same slope, there will be those conditions. This means what? They have different slopes. So if they have different slopes, they will always meet, right? So that's the condition for the system linear equations, right? So let's look at the example on the page 3. What we are talking about? We say Without graphing, determine the number of solutions of system. The number of solutions for the system can either be what? 1 or none or infinite, right? We wanted to decide, which one is that for the situation we have, right? So if we look at the example 1, so here is x minus y equals 2, x equals 2y plus 5. We say first, to decide how many solutions, what the styles, how these two lines are, first we decide by the slopes. If different, we know we have one solution. If the same, we can have two cases. Then further on, you use what? Intercept to decide, right? Intercepts are different, that would be this case. Intercepts are the same, that would be this case. So first we decided by what? Slope. How can we decide what's the difference between these two slopes? By doing what? Use slope-intercept form. Is that right? If I have y equals what? Y equals mx plus b, then I can decide if I have same slope. So what do we need to do? Change to slope-intercept form. So, like this one, how do we change it to slope-intercept form? Means you have to get what? Y by itself. So your minus half x, right? We have negative y equals negative 1, half x plus 2. But the y still not by itself, right? So what do? Divided by negative 1. So we have y equals half x minus 2. Is that right? So for the first one, slope is what? Half. Right? Then for the second one, then what is slope is half, and what is its y-intercept? Because we decided by slope, also decided by y-intercept. Y-intercept is what? Negative 2. Is that right? Okay. Then for the second one, we get a y by itself, so we minus 5, right? Move things away. 2y equals what? X minus 5. Then divided by 2. Y equals what? Half x minus 5 half. So second one, the slope is what? Half. Y-intercept is what? Negative 5 halves. So what does this one tell me? They have the same slope, but they have a different intercept. That means what? These two lines are parallel, and it's no solution for the first one. Right? So how do we make a decision? First, we use the slope. See they are same or not. If they are same, then we look the y-intercepts to decide it is no solution for the system or infinite solution. Right? So what do? First step, you will change everything to slope-intercept form. Right? Step 1, before you can decide what kind of slope it is. Then second one, we will compare what? Compare the slopes and the intercepts to decide it further. This condition or this condition. Infinite solutions or no solution. Let's take a look second example. So 3x minus y equals 4, x plus 2y equals 8, right? So first, we'll change it to slope-intercept form. So what do? We will get y by itself, right? So get y by itself by doing what? Move x away, right? So what do we have? Negative y equals negative 3x plus 4. Get y by itself, right? So what do we have? Y equals 3x minus 4. So first one, the slope is what? 3. And for the second one, get the y by itself, right? Slope-intercept form we are using here. So minus x, so 2y is what? Negative x plus 8. Then divided by 2, so y is what? Negative half x plus 4. So one equation is this one, another equation is this one, right? Look at their slopes. Are they the same? They are different. One is 3, one is negative half. So if slope is different, that means how many solutions we have? One solution. So this part, we are just clarify the concepts for the two lines. How do they behave? What kind of solutions we can expect? Instead of finding the solution, right now we just decide how many solutions there possibly be, right? So that's page 3 for section 5.1.